Okay?
Yeah.
All right. Okay, so double displacement or double replacement. They're the same things. You'll hear them both used interchangeably. In your notes, it says double displacement. It's V. But you'll hear me call them double replacement. You'll hear me refer to them as double replacement. This is the big thing about double displacement or replacement is that they switch places. Now that seems really super easy, that you have AB plus CD yields AD plus CB. They just switch places, right? So instead of the A being with the B, the A is with the D. Instead of the C being with the D, the C is with the B, okay? On the surface, it seems really easy. It gets a little more difficult, and you have to start dealing with this. I put this in the reference section, or it's on Google Classroom under reference sheets. It's called a solubility table. If we were at school, you would have one laminated in your notebook, but we're not, so you're gonna have to deal with just the picture that I have. And this makes it just a little bit more complicated. It's nothing you can't handle. I have total faith in you, but it makes it a little bit more complicated, that's all. Okay, so let's start with this. We switched places, right? We want to think about this for a minute. A is positive, C is positive. We know that because they come first. Whatever comes first in our formula is always positive, okay? Which means that the A has to be first over here and the C has to be first over here because they're positive, okay? When the A goes with the D, you end up with this. You end up with AD. The A goes with the D because the D is negative, okay? So you have positive, negative, right? The C goes with the B because the C is positive and the B is negative. That's why the C over here comes first because it's positive, okay? So you have to keep those straight. Your positives always have to go first. Your negatives always have to go second. That's how you know what goes with what. That's how you know who changes partners, okay? Positive go here, positive here, negative here, negative here. So positive with negative switches to positive with negative, okay? Positive with negative here switches to positive with other negative, okay? Make sense? All right. Now, this is where this starts to get a little bit more involved. They're going to tell you that you have lead 1 nitrate, and that's aqueous. They'll tell you somehow that that's aqueous. I know it's aqueous because NO3, right here, nitrate, NO3 has nothing in its exceptions. I'll explain that later. Adds to calcium chloride, and that's aqueous. I know that, and again, I'll show you this later, but I'm just giving you a little preview. Chloride, Cl, is only solid, chloride is only a solid if it's with Ag, Hg, or Pb. It's with calcium, so it's aqueous. So anyway, they're going to tell you that you add these two things together. They want to know what kind of reaction you get. They want to know if there's a reaction. Okay? Our accent again is reaction. Okay, so the very first thing you have to do is you have to go back into your memory bank and figure out how to write lead 1 nitrate and calcium chloride as formulas. So lead is Pb. It's +1. How did I know it was +1? Because it says it right here. Right? Charge. Roman numeral tells you the charge. Nitrate is NO3 -1. I know that because I memorized my polyatomic ions. When you drop your charges and cross them down, you get PbNO3. Okay? Plus, calcium is +2. I know that because I used a periodic table. It's in column 2. Chlorine is -1. I know that because I used a periodic table. It's in column 7 or 17. Drop your signs, cross them down. You get CaCl2. I'm going to move this over so that it doesn't look as weird. Okay. Now, both of those, I forgot to write in, are aqueous. Right now you know that because I told you. In a minute, you'll know that because you can figure it out. Okay? Now, we're going to switch partners, because it's double replacement. We know it's double replacement or displacement because you have two things and two things. So A, B plus C, D. Okay? So we're going to switch partners. When lead goes with chlorine and calcium goes with NO3. Okay? Again, positive goes with negative. Positive goes with negative. That's how we figure that out. So on the other side, we have PB, CL. PB again was +1, CL was -1. So when we drop our signs and cross them down, we get PbCl. Making kind of a mess here. We're going to leave room here because we got to say whether that's aqueous or solid in just a minute. Calcium is going to go with nitrate. So we're going to get CaNO3 We're getting that because calcium is +2 and nitrate is -1. Drop your signs and cross them down, you get CaNO3. Again, we need to know, we need to know whether that's solid or aqueous. Now, here's where the trick comes in. If this is aqueous and this is aqueous, you have no reaction. In order to have a reaction in a double displacement or double replacement reaction, you have to have a solid, liquid, or gas in your product, okay? Most of the time it's a solid because you're using this table and these are going to tell you where your solids are, okay? Sometimes it's going to be a liquid. Liquid's a good example of liquid would be water. If water was formed, it's a liquid, okay? Gas would be something like, could be something like CO2, or it could be oxygen, or it could be hydrogen. It could be any of your Broncliffs, okay? So if something like that is formed, if a solid, liquid, or gas is formed, you have a reaction. If this is aqueous and this is aqueous, it's no reaction. Here's why. Let's say this is a clear liquid and that's a clear liquid, okay? So you put these two clear liquids together and you just get two more clear liquids. Can you see that anything happened? No. But if there's a solid over here, you're going to get a precipitate. Remember that a precipitate is a solid that falls out of a liquid. So what you'll see when you put these two clear liquids together is you'll see a solid form come out of the bottom. So in your test tube, you put these two clear liquids together and something comes out of the bottom. There's some, all of a sudden there's a green solid at the bottom, let's say. That's a reaction. So let's see if we have one. The way we do this, you almost always look at your anion, your negative ion, okay? On the solubility chart, are we close enough? Mm-hmm. On the solubility chart, you'll notice that NH4 is there, K plus is there, and Na plus is there, okay? Those are your only positives that are showing, okay? Down here, other alkali salts that are soluble, Li, Rb, Cs, and Fr. Those are all positive as well. Oh, wait, no, sorry, francium isn't. No, francium is. No, francium isn't. Anyway, no, francium is. I'm sorry. Sorry, I keep going back and forth. I mean, I need a periodic table in front of me. Anyway, so those are positive as well. So you are going to, sometimes you'll have to look at your positives, but most of the time you're going to look at your negatives. So we have Cl right here, right? So we're going to find Cl on here. See how Cl is right there? Chloride, the chloride ion Cl, okay? Do you see how there's this S up here? I put that there for you so that you would know that if one of these things is present, it's a solid, okay? Now, if you have to look down at the bottom, these ones go the other way. If you have one of these things with something that's present here, all of a sudden it is soluble, so it's aqueous. But let's stick with the solid for now. Sorry. Was that too confusing? Mm-hmm. Okay. So chlorine, chloride, right? The chloride ion right here. Chlorine is soluble, which means it's aqueous, unless it's with Ag, Hg, or Pb plus 2. Now, is this Pb plus 2? Is it? No, it's Pb plus 1, right? So that means this is aqueous, okay? because it says it has to be with Pb plus 2, which means this would have to be lead 2 nitrate, not lead 1 nitrate. So you have to watch those things up here, Pb plus 2, Pb plus 2, Pb plus 2. You have to watch that, okay? So that's aqueous. I'm going to tell you right off the top of my head, nitrate never, ever, 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 ever is a solid. Look, nitrate, NO3, blank. Okay, so nitrate, anytime you see nitrate, you can just go, hey, that's aqueous. So guess what? We just did all that work for this. Okay, because this is aqueous and that's aqueous, which means you're not seeing any reaction. Okay, so let's try one more where there is a reaction. Ready? Okay, so we're going to go with iron 3, chloride, and we're going to do, okay. And we're going to do sodium acetate. Okay. All right. So those are the two things that are coming together. Now, let's take a look at this for a minute. Chloride is Cl, right? Chlorine or chloride is soluble, so it's aqueous unless it's with Ag, Hg, or Pb plus 2. It's with iron, so this is aqueous, right? Yes. Acetate, we know, is C2H3O2 minus 1 because we memorized our polyatomic ions. Acetate is soluble unless it's with iron, aluminum, or Hg. It's with sodium, so it's aqueous. Okay? So now we got to put these guys together into our formulas. Ready? Iron is Fe. It's plus 3. I know that because it's right here. Okay? Chloride is Cl, and it's minus 1. We drop our signs and cross them down. We get FeCl3. I'm going to move that over so that it looks nicer. And we already know that that's aqueous. Plus. Sodium is Na. Na is plus 1. Acetate, we know, is C2H2. Oh, I'm sorry, H3. Sorry. Delilah, I didn't memorize my polyatomic ions. O2. Actually, I did. I just made a mistake. So C2H3O2, and that is negative 1, okay? When you drop your signs and cross them down, you just get that, okay? Get that out of there. We already know that that's aqueous because we set it up there, okay? Now, we're going to switch partners. Iron is positive, sodium is positive. Chlorine is negative, acetate is negative, okay? So iron is going to go with acetate, sodium is going to go with chlorine, okay? So we're going to end up with Fe C2H3O2 3. Stop for a minute. How did I come up with that? Iron is plus 3. Acetate is minus 1. When you drop your signs and cross them down, minus 1 plus 3, you get this. Okay? Okay. We're going to leave our little parenthesis there because we're going to come back to that. Plus, Na goes with Cl. Na is plus 1. Cl is minus 1. When you cross your signs and drop them down, you just get NaCl. Okay? And again, whoops, we're going to leave that open. Okay? So let's see if we have a reaction. Again, we're going to look at our negatives. Okay? So, acetate, right here. Acetate is soluble unless it's with iron plus 3. Oh, look what we just found. It is with iron plus 3, isn't it? So guess what? That's a solid. Okay? So again, acetate is soluble, which means it's aqueous, unless it's with iron plus 3, aluminum plus 3, or Hg2 plus 2. And yes, oh no. So we know that we had iron plus 3. So it's a solid. Again, if it's with any of these things here, it's a solid. If it's not, it's aqueous. Okay? So now we're going to look at chlorine. Chlorine is aqueous unless it's with Ag, Hg, or Pb plus 2. It's with Na. So it's aqueous. The other thing you could have done, because sodium is here, sodium doesn't have any exceptions. It's always soluble. So that means that would have been aqueous anyway. Okay? But now we have a reaction. Just because we have a solid in the products, we have a reaction. Okay? So that's double displacement. Couple things you have to remember though. Again, most of the time it's going to be this solid that you're looking for, okay? But let's say they say to you, they give you something like, let's see. They give you something here. They say to you, water is added to baking powder, carbon dioxide bubbles form. That's a gas, which means that was a reaction. Lemon juice is added to household ammonia. Water is one of the products. Water is a liquid, which means that's a reaction. So do you see the whole solid liquid gas thing works? Okay. So most of the time when you're dealing with double displacement, you're going to have a solid, but you can have a gas or a liquid to have a reaction. Okay. So the other thing I want to talk to you about real fast is down at the bottom. Okay. Down at the bottom, like you have carbonate, for example, and oxide and phosphate. So let's do one of those so that you can see what that looks like. Abby's getting tired of holding the camera. I'm sorry, Ab, I'm almost done. Okay, so let's do Na2CO3 plus Abby's neck hurts. Okay, so let's look at this one. So let's say they gave you this, Na2CO3, so that's sodium carbonate, okay? Carbonate is -2, sodium is +1, that's why there's 2 sodiums. Magnesium phosphate. Magnesium is +2, phosphate is -3. Drop your signs and cross them down, you get Mg3PO4 Okay, so when you switch partners on this, or actually when you're just looking at this, you could look at Na here because Na is on the top, right? And we said Na doesn't have any exceptions, so there's nothing that makes it a solid. So this is obviously aqueous. But you could have looked down here. Carbonate is right there. Now, these ones are insoluble unless they're with these things. Alkali metals or ammonium make them soluble. Na is an alkali metal, okay? So that is why that's soluble. Mg3PO4, we're going to have to look at PO4. We're going to have to look at phosphate because there's no Mg up here. So phosphates are insoluble unless they're with alkali metals or ammonium. That means this is a solid, okay? So generally you have two things together that are going to be aqueous and aqueous, and then you're going to see if you get a solid in the product, but it doesn't always have to happen that way, okay? So that's how you figure that out, though, that's really what I wanted to show you, was the whole phosphate thing. See, phosphate is insoluble, which means it's a solid. So this means it's a solid unless it's with an alkali metal or ammonium. If you look at your periodic table, your alkali metals are right here, right, in your first column. Mg is an alkaline earth metal, right? So Mg doesn't qualify, which makes that a solid, okay? So then you would just go through and do the rest and see if you got a solid in your product. Really what I wanted to show you was how you figure it out if you happen to have something that's not up at the top. I want you to give these a shot. What I want you to try is this. If I could get back to my correct place here. No, not that, sorry. Over here. Right here. So, a couple of these, like number 6 or number 7. Try number 6 and number 7. Those are both very good. See if you can come up with something. So give those 2 a shot. So it's number 6 and number 7. They're in the back of your notes. So this is the end of your notes. This is past this. Go to 6 and 7. Give those a shot. See what you can do. I did put a couple on the quiz. Give them a shot. See what you can do. Send me reminds with questions. Sorry the video is so long, Abby. Bye.